This lesson is called Classifying Triangles. We'll start out by talking about triangles by its angles, then we'll jump into stuff that talks about it by its sides, and then we'll throw some algebra at you to make sure you can solve some equations still. All right, the first type of angle, if it has three acute angles, that is called an acute. If it has one obtuse angle, which means it's bigger than 90, that is obtuse. If it has one angle that's 90 degrees, we call that a right. And if it has three congruent angles, we call that equiangular. And we know that all three angles inside of a triangle have to add up to 180 degrees. So each of these angles would have to be 60 apiece. So for equiangulars, every angle is 60 degrees. It says use a diagram to classify each triangle by its angles. All right, so triangle CDE. CDE. Well, it has a 90 right here, so that makes it a right. BCE, I see this guy has an angle bigger than 90, so that makes it obtuse. Triangle ABE, all three angles are the same, that makes it equiangular. Triangle BDE, well, I see all of E has an angle bigger than 90, so that would make that obtuse. Triangle CFE, it appears all angles are less than 90, so that's going to be an acute. Next up, classify a triangle by its sides. The triangle has three congruent sides. We call that equilateral. If it has two congruent sides, we call that isosceles. If it has no congruent sides, we call that scalene. Use a diagram to classify each triangle by its sides. Triangle JKM. Well, it appears that all three of these sides are all different, so that's going to be scalene. Triangle KLN. This guy has two congruent sides, so we call that isosceles. Triangle JKN. All three sides are the same, equilateral. Nine to 14 says classify each triangle by its angles and its sides. So one word from the angles part and then one word from the sides. Has a 90, so that's a right. Two congruent sides, isosceles. Angle bigger than 90, obtuse. And since I don't have any marks on any of the sides, I have to say scalene. All angles are congruent. All sides are congruent. That's equiangular, equilateral. Let's see. All angles are less than 90. That's acute. All angles are different, or all sides are different, scalene. 13 has a 90. That makes it a right. Since the sides have no markings, we have to say scalene. Angle bigger than 90, obtuse. Two congruent sides, isosceles. Next page. Directions play a big part in this guide from 15 to 20. Says if segment PR, which is this segment right here, bisects angle SRT, which means this segment cuts this angle in half. So if that side's 30, this has to be 30 right here. Also says that U is the midpoint of RT. So if this is the middle part and that side's 8, this side right here also has to be 8. Classify each by its angles and its sides. Triangle UQR. UQR, this guy right here. Angle bigger than 90, that's obtuse, and has two congruent sides, isosceles. So obtuse, isosceles. Triangle RST. We have a 60 here, a 60 here, and a 60 here. That makes equiangular. And if it's equiangular, it's always going to be equilateral as well. Triangle SQR, I see a 90 right there. And then I also notice that all three of these sides are different, so it's going to be a right scalene. PRT. All right. This angle right here total is definitely bigger than 90, so that's going to be an obtuse. And I noticed that this side over here adds up to 16, and this side is 16. So two congruent sides, it's going to be isosceles. Triangle TQU. This guy right here. Well, check us out. If that side's 8, that side's 8. So we know all sides are the same. So that's going to be equilateral. And if it's equilateral, it's automatically equiangular. So all these inside are also going to be 60. So equiangular and equilateral. Triangle PQT. Well, I see I have a 90 right here, so it's going to be a right. And then I don't know much about the sides, but they all appear to be different. This side's 8, that's 16, that's going to be something different. So that's going to make it a scalene. For the next 4 problems, I'll show the work on one of these, and I'm just going to give you answers on the next 3, and you can check the key from the Google Classroom to see how the work is done. But here's our job. It says find the measures of all the sides of triangle JKL, then classify by its sides. So if you kind of think about this, you have a triangle JKL, and your job is to find the distance between each of the sides. So to do that, we have to use the distance formula. So just kind of recap, remember distance, you subtract the x's, square them, subtract the y's and square them. So big square root, subtract the x's, square them, add that with the subtraction of the y's and square that. So we have to do this 3 times. We got to find the distance between JK, distance between KL, and the distance between JL. All right, so J and K, using these 2 points first, I got to subtract the x's. I'm going to go -7 minus a -9. And remember, it turns into a plus. Subtract the y's, -7 minus 1. Square it. If you type in the stuff underneath the square root, that comes out to be 68. Use points K and L for the next piece. So this guy here and this guy here. Subtract the x's. -9 minus a -1. So -9 plus 1. Do the y's. 1 minus a -1 turns into a 1 plus 1. Type in the stuff underneath the square root, that comes out to be 68 as well. So far, right now, we have an isosceles, right? JL. So use the first point and the last point. Subtract the x's. -7 minus a -1 turns into a -7 plus 1. Do the y's. -7 minus -1 turns into a -7 plus 1. That stuff comes out to be 72. So I have 2 congruent sides, which makes this an isosceles. Solis. I will give you the answers for the next three. I encourage you to look at the note keys to show the work for these ones. But number 22 comes out to be scalene. 23 is isosceles. And 24 is also isosceles. Check the key on the notes to show work, to see the work for 22 to 24. Next page. These are some more questions that you're probably going to see on a quiz from us, guys. It says if ABC is an equilateral, that means all sides are the same. Solve for both x and y. Well, if one side's 49, they all have to be 49. So set each of these expressions equal to 49 and solve for x and y. So first one, 3x plus 1 is 49. Subtract the 1 over, divide by 3, that comes out to be 16. For the y's, 18y minus 41 is 49. Add the 41 over to get 90, and 18 goes in there 5 times. Number 2, RST is equilateral. So once again, all sides are the same. Find x. So we have options here. Since I know that all sides are the same, I can pick any two of the sides and set them equal to each other because they are congruent to each other. I'll just work with the top two. 12x minus 22 is 10x minus 6. I'll subtract the 10x to the left. I'll add 22 to the right. Gives me 16, and 2 goes in there 8 times. Then it also says find the measure of each side. So your job, you got to plug this back in to all 3 pieces. And every side comes out to be a nice even 74. So all sides are 74 each. Number 3, once again, we have an equilateral triangle. All sides are the same. Same thing for number 2, guys. Pick any 2 sides and solve for x, and then you got to plug it back in to find the measure of each side. So once again, I'll work with the top 2. 4x minus 25 is x plus 14. Subtract 1x to the left. I'll add 25 to the right. That gives me 39. And 3 goes in there 13 times. Now plugging it back in to all the sides, that comes out to be 27 on each side. Number 4, triangle DEF is isosceles, and DE is congruent to EF. So DE is congruent to EF. All right, these are the only 2 congruent sides. Set them equal to each other and solve for x. 8x minus 13 is 5x plus 17. Subtract 5x to the left. Add 13 to the right. X comes out to be 10. Plug it back into all 3 sides. When you do that, you'll have a 67, a 67, and a 31. Number 5, WXY is isosceles, and WX is congruent to XY. Set those guys equal to each other. Solve for x, plug it back in. 6x minus 77 is 3x plus 4. Subtract 3x to the left. Add 77 to the right. And 3 goes in there 27 times. Plug it back into all 3 sides. Your sides come out to be 85, 85, and 104. Next page. All right. Says triangle PQR is an equilateral triangle, so all sides are the same. Find x, plug it back in. So if it's equilateral, pick any 2 of these expressions, set them equal, and solve. I will work with the first two. 18x plus 1 is 24x minus 17. I'll subtract 18x to the right. Add 17 to the left. And 6 goes in there 3 times. Plug it back into all 3 sides. The sides come out to be 55, 55, and 55, which makes sense because it's an equilateral triangle. Number 7, once again, we have an equilateral triangle, but now we got to come up with some expressions to figure out what they're talking about here. So let's set one up for ST, SU, and TU. All right. ST is 1 less than twice x. That would be 2x minus 1. SU is 37 less than 5 times x. That would be 5x minus 37. TU is 11 more than x plus 11. Once again, it's equilateral. Pick any 2 sides, set them equal to each other, then plug it back in. I will work with the first 2. 2x minus 1 is 5x minus 37. Subtract 2x. Add 37. And 3 goes in at 36 12 times. Plug it back in. Sides come out to be 23, 23, and 23. The best basketball player ever wore number 23, and it wasn't LeBron James. Michael Jordan. Number 8, triangle MKL is isosceles with these 2 pieces congruent to each other, MK and ML. So this guy is congruent to that guy. So those are the 2 sides that we have to set equal to each other because those 2 sides are congruent to each other. Then once we're all done, plug it back in all 3 pieces and get your sides. 7x minus 15 is 10x minus 42. Subtract 7x to the right. Add 42 to the left. That gives me 27. And 3 goes in there 9 times. Plug it back into all 3 sides. That comes out to be a 48, a 31, and a 48. Number 9, ABC is isosceles with these 2 pieces congruent, AB and BC. So set these guys equal to each other, solve for x, plug it back in. 3x plus 41 is 8x minus 54. Subtract 3x to the right. Add 54 to the left. That gives me 95. And 5 goes in there 19 times. Plug it back into all 3 sides. You'll have a 98, a 98, and a 125. Number 10, this guy is isosceles with these 2 pieces be congruent. But once again, we got to come up with expressions for the triangle. So we got expression for GH, HI, and GI. All right, GH, 3 more than x plus 3. HI, 17 less than 4 times x, 4x minus 17. GI, 45 less than 6 times x, 6x minus 45. Okay, remember, these are the 2 pieces that are congruent to each other. So set these first 2 equal to each other. I'm sorry. GI and HI, last 2 set equal to each other. So 6x minus 45 is 4x minus 17. I'm going to subtract 4x to the left. So 2x minus 45 is negative 17. Add 45 to the right. 2x is 28, and 2 goes in there 14 times. Plug it back into all three pieces. You'll have a side of 17, a 39, and a 39. That is the end of the lesson.